Day 523 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 509, Fibonacci number. The difficulty level is easy, so you already know we're going to keep the solution as simple and easy to understand as well. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. The Fibonacci numbers, commonly denoted as f of m, form a sequence called the Fibonacci sequence, such that each number is the sum of the two preceding ones, starting from 0 and 1, that is. So f of 0 is equal to 1, f of 1 is equal to 1, and f of n is equal to f of n minus 1 plus f of n minus 2 for numbers that where n is greater than 1. Given that n, calculate f of n. All right, y'all, so that sounds pretty simple, but let's go ahead and take a look at these examples anyway, just to make sure that we are doing this problem correctly. So in example 1, we have n equals 2. Our output is 1. Explanation says f of 2 equals f of 1 plus f of 0, which equals 1 plus 0, which equals 1. So they give us f of 1 and f of 0 right up here. So f of 1 is equal to 1, f of 0 is equal to 0, and since n is equal to 2, we want to do f of 1 plus f of 0 because f of 1 is 1 less than f of 2 and f of 0 is 2 less than f of 2. Hence this right here. Boom. So, but given that we already know what f of 1 and f of 0 is, it's just 1 plus 0, which equals 1. So let's take a look at example 2 where it's a little bit more tricky because we have to deal with elements, or excuse me, we have to deal with integers that are just not already given to us with f of 0 and f of 1, right? So let me show you how the Fibonacci sequence works before we get into example 3. So, or what it looks like. So it'd be 0, 1, 1, 2, 3, 5, 8, 13, and so on and so on. So as you can see, we just did 0 plus 1, that gave us 1. Then we did 1 plus 1, that gave us 2. Then we did 1 plus 2, that gave us 3. Then we did 2 plus 3, that gave us 5. So what we're doing, we're just taking, if we, this number is just going to be equal to the previous two numbers added together, right? So, or the sum of the previous two numbers. So this right here is the sum of the previous two numbers. This right here is the sum of the previous two numbers. This right here, sum of previous two numbers. And that's how the Fibonacci sequence works. And I'll show you why that's important when we go through these examples. So in example 2, we have our input equals 3. Our output is equal to 2. And the explanation says f of 3 is equal to f of 2 plus f of 1, which equals 1 plus 1, which equals 2. So when they're saying n equals 3, they're not saying the number 3. They're saying f of 3, right? So the Fibonacci of 3. So that means not sequence. That means index 3 in the Fibonacci sequence. So index 3 in the Fibonacci sequence would go 0, 1, 2, 3. So this would be f of 3 right here. Then we want to get f of 3. So once again, f of 3 would be f of 2 plus f of 1, which is 1 plus 1, right? So that's 1 plus 1, which gives us 2. So now we know f of 3 is equal to 2 because the third index of the Fibonacci sequence is equal to 2. Now let me show you why that's important, and because we need to look at this sequence. We're not just looking at the number 3, because say we did n equals 3, right? We're not saying that it's 3 minus 1, which equals 2, and plus 3 minus 2, which equals 1, because 1 plus 2 would equal 3. That's not what we're saying. You see, because this would be, 2 would be n minus 1, right? And then 1 would be n minus 2, right? But no, we don't want that. We want the Fibonacci. We want minus 2 of the Fibonacci sequence, or minus 2 of the Fibonacci array, or not array, but sequence, right? So we want minus 2. When we say minus 2, we mean this 2 minus 2 in the Fibonacci sequence. So that'd be this 1 plus this 2 minus 1 in the Fibonacci sequence, which would be this one. So it'd be 1 plus 1. We're not doing it like this. That's not the Fibonacci sequence. We are only worried about this right here, the Fibonacci sequence. And then if n equals 3, that means we want to know what is the third index of the Fibonacci sequence. And to find that, we have to do f of 2 plus f of 1, which would be 1 plus 1, and that's going to give us 2. Boom. So similarly, when in example 3, when n equals 4, the output is 3. Explanation says f of 4 is equal to f of 3 plus f of 2, which equals to 2 plus 1, which equals to 3. So this time we're looking, f of 4 is asking, or excuse me, when the input 4 shows, that's asking what is the fourth index of the Fibonacci sequence. So as you can see, the fourth index of the Fibonacci sequence would be 0, 1, 2, 3, 4, would be 3, just like it's supposed to be, right? 3, boom. How did we get that? We did f of 3 plus f of 2. So f of 3, if this is f of 4, then this would be f of 3, and this would be f of 2. So f of 3 plus f of 2 is equal to 3. And that's how we got our output 3, and that's what this explanation is saying, y'all. So I hope that makes sense to y'all. Just remember, this is n equal 4. We're not talking about the number 4, because that kind of tripped me up when I was coming up with the solution. But we're not talking about the number 4. We're talking about the fourth index of the Fibonacci sequence. So just keep that in mind as we're writing our code. So now that we understand the question, y'all, let's get into the fun part, the actual solution. Solution is not that difficult, and guess what, y'all? Guess what? We got 2 solutions today, so make sure you stick around for the second one so you can see which one you like better and learn from both. So for the first solution, the first thing we want to do is we want to check to see if n is equal to 0 or 1, and then we could just return it directly because of the Fibonacci sequence. We already know if f is 0, that equals 0, and f of 1, that equals 1. So we could just say guard n is greater than 1, else we can open up the bracket and return n. Boom. Then we need to initialize the first 2 Fibonacci numbers, meaning f of 0 and f of 1. So to do that, we're going to declare a variable called a, set that equal to 0. So that's going to represent f of 0. Then we're going to declare another variable called b and set that equal to 1. And that's going to represent f of 1. Boom. So we could just say, we could just start comment this right here so y'all can see what's going on. Boom. Then we could come right here. Now we're going to loop from 2 up to n to compute the ith Fibonacci number, because we already have 0 and 1, so we're going to start from 2. So we're going to say 4 underscore n 2 dot 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 n, so 2 up to n. Then we're going to open up the brackets, and we're going to temporarily hold the next Fibonacci number, which is the sum of the previous 2. So we're going to say let temp equal a plus b. Now this temp is important because what I was talking about earlier, when we're dealing with numbers like 3 and 4, or we're dealing with numbers after 2, after index 2, after f of 1 and f of 0, once we get to dealing with f of 3 and f of 4 and so on, we need to store the previous values, because like I said, 3 is not going to be 3 minus 1 plus 3 minus 2. It's going to be the Fibonacci index 3 plus is going to be equal to the Fibonacci index 2 plus the Fibonacci index 1. It's not just the numbers 1 and 2, it's the Fibonacci indexes that we're adding together. So that's why we need to store the previous Fibonacci or the previous Fibonacci numbers, so that we will be able to add them together, and we won't just be adding 1 plus 2 when n equals 3. Boom. Then we're going to move our window forward. So the OB is going to become the new A. So we're going to say let A equals B. And then the OB or temp is going to be the new B. So we're going to say B equals temp. That's why we're storing it right here. Boom. Then all we have to do is come right here and say return B. Boom. That's all she wrote. That's all the code, y'all. Let's give it a run. Make sure it runs properly before we submit it. Let's see, it's accepted. So let's go ahead and submit it and make sure it's still accepted after we submit it. Ooh, look at that, y'all. 0 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see. That was with the big O of N time complexity. Now, guess what, y'all? Guess what? We got a one-liner. That's right, y'all. The second version of the solution is only one line of code. That's why you know I had to include it in here. I want y'all to remember that that first solution I gave you is big O of N. This one-liner is a little slower. It's big O of 2 to the N, which is a little slower than big O of N, but I'm going to give it to y'all anyway. So for the one-liner, all we have to do is we are going to say N is less than 1, boom, which is going to return a true or false, or a Boolean. We're going to say question mark. If that's true, then we could just return N, similar to how we did with our guard statement in the previous solution. Else, we're going to say colon, and we're going to say ABS, which is going to get us the absolute value. We're going to open up the parentheses, and we're going to use some recursion here. So we're just going to say fib, open up the parentheses, N minus 1. Then we're going to come outside of those parentheses, still inside the other parentheses. We're going to say plus fib, open up some more parentheses, and say N minus 2, y'all. And boom, it's just that simple. Let's give it a run. Make sure it runs correctly again before we submit it. It's accepted, so let's go and submit it, see what happens after we submit it. And look at that, y'all. 23 milliseconds beats 5.78% of users. Like I said, that is a big O of 2 to the nth power. Time complexity is it's very much slower. However, I wanted to include it just so y'all can see how we can use some recursion and dynamic programming, as well as just give you an easy to remember solution in case you all ever come across this problem in an interview or some sort. So with that being said, y'all, make sure you get one more look at the code. And I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.